Now let's think about the energy in simple harmonic motion. So we'll consider an equation that we've been dealing with before, that is x double dot plus k on m times x. So it's mass on a spring. Now we think about the motion of this mass, and at the moment where the mass stops moving and turns around and starts going the other direction, the kinetic energy falls to zero, so all the energy in the system must be stored as potential energy in the spring. The kinetic energy is zero. Conversely, at the moment the mass passes through the equilibrium position of the spring at x equal to zero, the spring contains no potential energy and all the energy in the system is contained as kinetic energy of the mass. So the energy is sloshing between kinetic and potential, kinetic and potential. The total energy of the system at any time must be given by the sum of kinetic and potential energy. Writing that down, the total energy is sum of kinetic and potential, or half mv squared plus a half kx squared. That's the total energy. If we drew a graph of it, you'd see they're oscillating sinusoidally like this, and you add them together and you'd get some constant. So let's write down these functions explicitly in terms of the solutions we have for x. We'll consider motion of the form xa sine omega t plus phi. So that's one possible solution of this equation. Therefore, the total energy must be the sum of the kinetic energy, so that's a half mx dot squared. Derivative of the sine function gives you a cos, and you square the cos. There's an omega squared that comes from the derivative, so we have a squared omega squared m on 2 cos squared omega t plus phi. And here we have a half k x squared. So that's the total energy. But a squared omega squared m, that's on 2, that's this factor out the front here, must be equal to a squared k on 2 because omega squared is equal to k on m. So we can cancel the m and replace all this stuff up top here by k. But if a squared omega squared m on 2 is equal to a squared k on 2, then what we have in fact is some common factor outside of cos squared plus sine squared. And that common factor is either a squared on 2 omega squared on m, this one, or k a squared on 2, since they're equal. So the total energy can be expressed either in terms of the frequency or the string constant.